Okay. Order of operations is a very specific method to make sure that everyone gets to the same calculation. And that's the whole point of it. Anyone around the world, they follow this order of operations for mathematics. And there's lots of reasons for it. That's why I ended up getting a math degree in college, was to understand really the purposes of why these things exist. You just need to know how to use them at this point. You don't need to know why they exist, but just know people have thought about why do these things exist and why is this the best way of doing it. And everyone does it, even the aliens. All right. And that's not a joke. Math works across the universe. All right. This is another key concept on page 10. You can see there's multiple steps. The first step is always to evaluate expressions in grouping symbols like parentheses or brackets or even fraction bars. Like 3 plus 5 over 3, you have to make sure that you add the 3 and 5 together first and not just cancel out the 3's. That does not work. You do not want to do that. So, you're going to evaluate all the powers, which means exponents. Then you're going to multiply or divide, and this is the important part. This is what everyone always gets wrong on those Facebook posts about this stuff, is it's from left to right. And then you add or subtract from left to right. So if you have multiple parts in there might be in different parts of the expression. It might be a really long one. You have to make sure you do the division and multiplication from left to right. You don't always just do the multiplication first. You do it from left to right, just like you're reading a book. All right. Example 2, order of operations. So when I'm looking through this, I don't see any grouping symbols. There's no parentheses, there's no fraction bars, there's no brackets, there's nothing like that going on. So I can kind of skip step 1. Step 2, I do notice that there are some exponents in there. So that's the part I'm going to take care of first. So the 16 minus 8 divided by, nothing is happening to it so far. I just want to take care of the exponents, all the powers. 2 squared is 4. 2 times 2 is 4. Plus 14. All right, now I've taken care of all the powers. I check step 3, multiply and or divide from left to right. I only have one division, no multiplication. And I've got the division. Oops. Chose the wrong marker there. Right here. So I need to do that division first. So 16 minus 8 divided by 4 is 2 plus 14. And now I just have subtraction and addition, which is the 4th step. And I'm going to do it left than right. And the most common mistake here is because it's usually we say add or subtract. Like if you remember the whole PEMDAS thing, it says parentheses, exponents, multiply, divide, add, subtract. There really should be an or between the M and the D and the A and the S. And that's because here I need to do the subtraction of 16 minus 2 first. 16 minus 2 is 14. And then I add the 14 together, and that is 28. Now, I did each one of those things one single operation at a time. And when you first begin, if you're not comfortable with these, just do one at a time. It will take longer, but you'll be more sure of your answer when you get to the end. Because every step you can stop and think, what am I supposed to be doing here? Multiplying. Left to right. What's the first one I got to do? Okay, take care of that one and then rewrite the step. You don't want to do too many things at once unless you really know. Like someone like me, who's been doing this forever, I could do that one in my head, particularly because I've done this example specifically a bunch of times, right? Every time I do it, I go, oh yeah, that's the answer's 28, like halfway through the problem, because I just remember it. But if you're not comfortable with your skills in this, go slower, more steps. If you feel like you could have done that last bit where 16 minus 2 plus 14 all at one, do that. But don't do too much at once, because then that's where errors come in. All right, I'm going to stop the video here, and then we'll have example 3.